Standard form function 2, so we're still in the properties of functions. This time we're going to look at the learning target 3, and we're going to look at a graph. So we are going to have 4 different videos. The first one's going to be graph, and then there'll be one on tables, and one on equations, and one on scenarios. So there's 4 parts, and this is going to be the first part, which is on graph. So I can identify the properties of a linear function given in an equation, table, graph, and or context. And we, again, as I said, are going to look at just graphs in this first one. An example of what we're going to identify, so these properties I'm talking about, is the rate of change, we know it as the slope, or the y-intercept. So a quick definition that's very important that you will use not only in this 8th grade year, but in algebra, algebra 2 in the high school and so forth, is the vocab word of slope. So when I'm talking about slope, and you're wondering, what is Miss Still talking about here? Slope of a line is the number that describes both the direction and the steepness of a line. So again, the slope of a line is the number. So it's a number. You can hear me say that. It's a number that describes both the direction, and we kind of talked about that in a previous video, positive, negative, 0 or undefined, and how steep it is. So I always think about skiing. You know, you have different diamonds, and I'm not a skier, so I'm not sure, but the steepness of a slope, the more steep a slope, the more dangerous, and the different coating they put on those ski slopes. So it's the steepness of a line. We're also going to talk about the y-intercept. And the y-intercept of a line is the point, and we always put it in an ordered pair when we're looking at the graph, where the line crosses the y-axis. And then what's always true about the y-intercept is that the value of x in the coordinate pair is always 0. And I kind of showed that up here, but that point is always 0. So it'll be 0, 4, 0, 5. And that point is where that line crosses the y-axis. So we are going to put these slope and this y-intercept that we're going to find in these graphs, and we're going to put it into something called slope-intercept form. So first of all, slope is seen as the letter M, and B is the y-intercept. So slope is not an S, it's the letter M, and the y-intercept is known as the letter B. So the slope-intercept form, just like it sounds, we're going to use the slope like we just defined and the y-intercept, and we're going to put it in this equation or this formula that is going to describe both that slope, so how steep that line is, and the y-intercept of where that line crosses the y-axis. So a formula for the equation of using a y equals mx plus b using its slope and its y-intercept. So it's a formula, or in Algebra 1, I call it the equation, that describes the line, or how steep the line is, which is your slope, and where it crosses on the y-axis, which is your y-intercept. So again, just a reminder to you, M, so this M right here, is the slope, so how steep, the number that is how steep or in the direction of the slope, and B is your y-intercept. So this format you're going to use all the time. It's y, so this would be your y values on your graph, equals, and notice this is a variable, by the way, so this is always a variable, it's always y, equals M, which is your slope, which is a number, x, which is another variable, so this represents the x values on your graph, and then b is the number of the y-intercept. And when you write, I know we talked about it as an ordered pair, where x is always 0, but this number that is in this blank here is what you technically put into b. You don't put the ordered pair 0, and then let's say it's 5. You don't put 0, 5, you just put 5. So let's look at a couple examples here. So here's my line, and we're going to put this into slope-intercept form. So we're going to find the slope and the y-intercept, and then put it in that form of y equals mx plus b. So what is the slope of this graph? So we're going to use what we learned before. I got to find 2 points. Let's just use this point And then if I look up, it crosses there at 1, 4, and it crosses at 0, 1. So remember, you draw your vertical and your horizontal line, which makes your right triangle. So now I'm just going to count my spaces. So I see it 1, 2, and 3. So my rise, or for some of you that like to do this change of the y or change of the x, my rise was 3, and my run is 1. So my slope is 3 over 1, or you can simplify that just to 3. Okay, now let's look at the y-intercept. So remember, the y-intercept is where this line, so start down here, notice it's a positive slope, by the way, because this is a positive 3. We start at the left, we're going up, and then as soon as it crosses the y-axis, so here's your y-axis here, where it crosses the y-axis is where the y-intercept is. So let me erase it so it's easier to see. So this point right here is on the y-axis, hence the reason why it's 0, because it's always 0 on the y-axis. This point right here is where the line crosses the y-axis. So our y-intercept here is 0, 1. So when you write it into the correct form, remember you're using y equals mx plus b, where y is any point on this graph and x is any point on this graph, and then you're just going to plug in what you know. So y equals, the number for the slope is a positive 3, and you can put 3 over 1 if you want. X is its variable, and b, remember we just talked about putting just the y value in there, is your y-intercept. So the equation to describe this beautiful line is y equals 3x plus 1. Now, I talked about one way you can check this is if you pick any point on this graph. So let's pick this point I picked up here already, 1, 4. And you could come down here and pick, where's it cross nice? Looks like -1, -2. You could pick that one too. If I pick either one of those points and I plug it into this equation, it should make the equation true. So if I take this 4, 1, my 4 is a y value, so I'm going to put 4 equals 3. My x value is 1, and if I add 1, which is my y-intercept, this should be a true statement. So 3 times 1 is 3, add the 1 is 4. That's true. That tells me this equation is really the equation for that line. You can plug in the 2. So this is our equation, remember? And we're just doing this to check to see if we actually made the equation right. So -2 is the y. 3 times the x is -1, add 1, so -2 equals, now this is -3 plus 1, which is -2. So again, I guarantee you that this is the equation that matches that straight line. And you could do that over and over. Any x and y value should plug into that equation and be correct. So we're going to find the slope. And this one's nice because it has points out for you, so we'll just do this slope right here. So here's my vertical, here's my horizontal. Notice I could tell by the way I did my vertical, I went downwards, which is negative slope, or I look left to right, I can see that's a decreasing. So my slope's going to be negative. Okay, remember you can write it as a change of the y over change of the x, or rise over run. So it's going to be a negative. I'm going to count 1, 2, or it goes from 3 to 1, which is -2, and my run is 1. So my slope is -2 over 1, or we could simplify that just to -2. The y-intercept, here's my left side. I go down, the line crosses right there. The y-axis right there, and that point is 0, 5. So I can write that there. And then our last step is just to plug it all in. So, plug it in over here. So we have y equals mx plus b. I'm putting it up there because I ran out of room. So y, remember, is any variable or any y value on that graph that's on the line. My slope is -2. My x value is any variable of x that is on that line plus the y-intercept, which is 5. So if I plug that in over here, if I pick any point, let's just pick this one down here. So that is 3, -1. So if I put -1 here, take negative 2 times 3 and I add 5, it better be negative 1 or my equation is wrong. So I either got the wrong slope or the wrong y-intercept. So negative 2 times 3 is 6, add the 5, negative 6, add the 5, and that does equal negative 1. So I can guarantee that that is the correct slope and y-intercept, and it's in the correct form.